Hi, in this video, I'm going to show you how to build three kinds of grating in PhotoCAD. Let's start with grating that there is transition grating on both sides and central grating is uniform. Let's define the parameters first. As shown in the figure, the SWG segment is the number of periods of central grating. Trans segment is the number of periods of transition grating on both sides. SWG width is the width of grating teeth. W length is the grating length of central grating. W length initial is the grating length of transition grating on both sides. And SWG period is the period of grating. Waveguide type is defined to use the default factory, and the default factory is fully edge wire waveguide on C-band. Before building the grating structure, we must calculate some parameters from parameters we just defined. SWG length is the total length of central grating. Trans length is the total length of transition grating on both sides. W step length is the equal length difference of transition grating. W length list is the length of all gratings from left to right. After we get these parameters, we can build grating in one for loop. Each grating is plotted in the shape of rectangle, where the width is the grating width. The height is corresponding to W length list. Layer is the core layer of defined waveguide type, and each rectangle is one period apart. Finally, each grating is filled in elements, and we can call the structure we just built and modify parameters here. If we say SWG segment is 5 and trans segment is 4, and run this code, we can see the grating is built like this. Or if we modify the parameters, we can plot the new grating structure. If we want to plot the uniform grating structure with no transition grating on both sides, we can just modify trans segment equals 0. And we set this SWG segment larger, like 9. And we can run this code and we can see, yeah, it's a uniform grating structure. The second grating is tapered grating. Tapered grating is similar to the grating we just showed. There is only transition grating on one side and no central uniform grating region. Still, we have to define the parameters first. Trans segment is the number of periods of tapered grating. SWG width is width of grating reach. W length is the longest length of tapered grating. W length initial is the shortest length of tapered grating. SWG period is the period of tapered grating. And waveguide type is defined to use a default factory, and default factory is FWG wire wire waveguide. After defining parameters, we can build the grating structure in function build. Same as the last grating, we have to calculate some parameters. Trace length is the total length of tapered grating. W step length is the equal length difference of tapered grating. W length list is the length interval of all the gratings from left to right. And we can define core area by a for loop. Draw SWG polygon by fp.el.rect and put SWG polygon into elements. Finally, in name, we can modify parameters here and run the code, and we can see a result of taper grating. Yep. Eventually, I'm going to show how to build a polarization beam splitter (PBS) based on the grating we just built. The PBS is referred to the publication of Professor Zhou at Beijing University in 2016. This is a schematic of the proposed PBS. Grating structure is embedded in a copper. Let's back to the code. We have a class which inheritance of fp.pcell. Then we have a function grow_curve which returns fp.g.line. We can modify length and anchor. This function is for us to build straight waveguide later. In function build, we can build the PBS structure here. Let's define the parameters first. W length is the longest length of grating structure. W length initial is the shortest length of grating structure. W width is the width of grating ridge, namely alpha here. Width is the width of waveguide, and gap is the distance between two straight waveguide. SWG segment is the number of periods of the central uniform grating region. Trend segment is the transition gratings number of periods. SWG period is the period of a grating, namely the lambda here. And we can put these parameters into the class SWG, the first grating we built in this tutorial, and put this grating in, and we can run this code. As you can see, the grating structure is already built. Then let's build these two straight waveguides. We put the function grow_curve we defined above into waveguide class fwg.c.wire and define waveguide length, anchor, and the two ports. Then we get a position of two ports. These two positions will be used later. And we use fp doublet to shift this waveguide downwards at a distance of width plus gap divided by 2. Then use the same operation to shift another waveguide upward at a distance of width plus gap divided by 2. Put these two waveguides into instance and run the code. Here we can hide the cladding layer. Then we can see the two straight waveguide is built. Back to the code. Uh, as you can see, outside the straight waveguide is the bending waveguide. Here, I'm going to build 4 short waveguides at these 4 positions and create a link between central straight waveguide and short waveguide. Still, we put the function rocker into waveguide class of fwg.c.wire and define waveguide length, anchor, and the port of waveguide, and use fpw to shift waveguide to the certain position. Then put these 4 waveguides into instance and run the code. Reload the GDS. Then we can see the 4 short waveguide is already built. Lastly, link between these waveguides. Here I use Euler band for bending waveguides. Put these 4 links into instance and put outer ports of 4 short waveguides into ports with corresponding name. Run the code. And it is the polarization beam splitter I'm going to show you today. Thanks for watching.